Hi everybody. Good morning. Sad that the weekend's over, I know, but good week to begin. I guess today is actually, because for me, it's 4-5. For you guys, it is 4-6. Which isn't as cool because we're doing 4.5 notes today and I thought it was 4-5 and that is not as cool at all, but whatever. Okay, so it's Puzzle Monday. So the first thing we're going to do is you should print off that Philippix puzzle number 2 that I put on here, or you could open it on a tablet or something you could write on and just draw on it if you like. That is due next Monday, 4/13. So make sure that you have that done by then, and you can send it to me by email. Next thing that we're going to do is we're going to do notes for 4.5, Arithmetic Sequences. Then we're going to talk a little bit about your quiz and talk about the homework. Okay. So, here we go. This is 4.5. We are skipping 4.4. I don't think it's worth our time. Today is 4-6. Okay. Now I know this looks like arithmetic, but it's actually pronounced arithmetic sequences. Not that you're going to be pronouncing it out loud to a whole bunch of people. So first, let's talk about what a sequence is. A sequence is a set of numbers that has a pattern. For example, you could have something like 4, 8, 12, 16, 20, etc. And you see the same pattern every time is that we're adding 4. But it's always the same pattern if it's arithmetic. So an arithmetic sequence, which is specifically the ones that we're dealing with today, and the reason why we're dealing with those is because they're directly related to like y equals mx plus b, that kind of thing. This is a sequence where you add and subtract. Hope you guys are taking notes with me and not just watching. The same thing every time. Okay, for example, this one up here is definitely an arithmetic sequence because it's adding the 4 every single time. That's also called a common difference. The common difference is the actual number that you are adding or subtracting. Each time. In the example up above, that was the +4 thing. Okay. Ick. That looks gross. There we go. Okay. So, now that we've got all that junk out of the way, let's talk about doing an example. So example 1 is this an arithmetic sequence? Okay, so the example is going to be 17, 14, 10, 7, 3. So for this one, let's see, first it goes from 17 to 14, that's a difference of -3. And then it goes from 14 to 10, that's -4, and then 10 to 7 is -3, and then 7 to 3 is -4. Now, you can see how this is kind of a pattern, like it subtracts 3, then subtracts 4, then subtracts 3, then subtracts 4, but because it's not subtracting or adding the exact same number every single time, the answer is no, it's not arithmetic. Okay, example 2. All right, for these, you have to determine the next three terms in the sequence. All right, so we're going to do two of them here. The first one is 11, 7, 3, -1, and then three things that you have to figure out. Next one is 31, 18, 5, something, something, something. Okay, this is an example that you should be doing yourself, so please pause the video and try it yourself. Grab a piece of paper if you haven't already, and give it a shot. I'll wait. You know, my cat is literally right here. This is Sparkles. This is Sparkles' feet. That's the top of Sparkles' head. She's a sweetheart. She really enjoys being involved in all of this. All right, you can feel free to head out, Sparkles. Okay. I assume you've done it by now. So let's see. 11 to 7 is -4, and then 7 to 3 is -4. 3 to -1 is also -4. So looks like the pattern is always subtracting 4. And it is an arithmetic sequence because it's always subtracting or adding the same thing. So this one's -5, this one's -9, and -13 are the final answers for that one. All right, the next one, it goes from 31 to 18. Again, this is subtraction 1, that's subtracting 13. 18 to 5 is subtracting 13 again. So we can assume that it's going to keep on subtracting 13 every single time, which makes this -8 and -21 and -34. So, hopefully you did those right. Let's go on to example 3. Alright, so for example 3, I'm going to have the numbers -4, -1, 2, and 5. And we're actually going to use this new definition, which is a formula. So make sure you write this one down. This is the most important thing in this lesson. This is the nth term of an arithmetic sequence. Okay, so here's the formula, and it's important to write down. This is a of n equals a of 1 plus n minus 1 times d. Okay, so a of n, this is your output, this is what you're looking for. N minus 1, n is what term you're looking for. And by term, I mean if you go back up to what a sequence is in the first place, like each one of these is called a term, each number. So if you're looking for, like for this one, for example, this would have been 1, 2, 3, 4, the 5th term that we're talking about. And so this one is whatever term you're talking about minus 1. So this is the term number minus 1. And that's in the problem, but then you're always going to have to subtract 1. And I'll show you how that works. This one is the initial term. That's that first term. And this one is the common difference, which we discussed earlier. Okay, so let me keep this definition up, or this formula up here at the top of the screen so we can all see it. And then I'm going to write some examples underneath. So let's go back to that example 3. It was -4, -1, 2, and 5. Now, it's pretty easy to find the 5th term because you realize, okay, I'm just adding 3 every time, just keep adding 3. But what if I said I want the 105th term? Well, that's when you would use this formula. So I'm going to write down the formula. A of n equals a sub 1 plus n minus 1 in parentheses times d. You should definitely be writing this down because this is hard stuff. Okay, so the initial term here, that's the first term right there. That's -4. And I'm going to have you guys find the 16th term without making a list. Okay, so this is going to be a of 16. That means that we're finding